So welcome students. In this question you are asked to find the center of the circle r bar dot I plus 2j plus 2k is equal to 15 and r bar minus of j plus 2k is equal to 4. So how does this represent the equation of a circle? So this equation is the equation of a plane. This is an equation of a sphere. R bar dot n bar is equal to constant is a plane. Modulus of r bar minus some vector, some position vector is equal to constant. That is, the point is at a distance of 4 units from j, 0, 1, 2. That's the meaning of this, which gives you a sphere. Now, if you have a sphere and a plane, the solution of these two will be a circle. And you're asked to find the center of the circle. So the center of this circle will be nothing but the foot of the perpendicular from the center of the sphere onto this plane. So the plane is nothing but x plus 2y plus 2z is equal to 15, right? That is the Cartesian form of this plane. And the center of the sphere, which is the distance from this point to any point, is equal to constant. So this will be the center. That is 0, 1, 2. So the center and the plane. So you just need the center of the circle. So I just need to find the foot of the perpendicular. So I have a formula for foot of the perpendicular. X minus 0 by x coefficient is equal to y minus 1 by y coefficient is equal to z minus 2 by z coefficient is equal to minus of, I just need to put this point in this plane, 0 plus 2 plus 4 minus 15 by a square plus b square plus c square is 9. That is equal to minus 15 plus 6 is minus 9, minus of minus 9 is plus 9 by 9 is 1. So this implies x by 1 is equal to 1, x is equal to 1, y minus 1 by 2 is equal to 1, so y is equal to 3, and z minus 2 is equal to 2, so z is equal to 4. So the center of this circle is 1, 3, 4. So this is the answer to this question. Thank you.